Okay, find all the solutions if x equals 5/3 is a factor. We can do synthetic division with a fraction. So let's set it up. Okay, so start my synthetic division, and 5/3 times 3. Sorry, 5/3 times 9. And it looks like I'm going to get 15. Okay, 3 times 5/3 will give me 5. And negative 6 times 5/3. Looks like negative 10. And there's my 0. And I am left with 9x squared plus 3x minus 6 equals 0. All right, is this factorable? Well, no perfect squares on A and C. If I take 9 times 6, I'm going to get a really large number. Yeah, I can't see it's AC factoring. It could be factorable, but it sure isn't easy to factor. So I'm going to use the quadratic formula. Right, I've identified my A, B, and C. Negative boy. Can't decide to go to a radical party. The boy is squared. He missed out on 4 awesome chicks. The party got over at 2 a.m. Now, I like to have blanks for all of my fill-ins. So B is 3, and for AC, 9, and negative 6, and 2 times 9. Okay, 4 times 9 is 36. Negative 36 times a negative 6 is 216. And that's over 18. Okay, 216 plus 9 is 225, which is a perfect square. That's 15 squared. So I'm going to keep reducing. X equals negative 3 plus or minus 15 over 18. This gives me 2 solutions. Negative 3 plus 15, so that's 12 over 18. And then negative 3 minus 15, negative 18 over 18. So my other 2 solutions, well, let's start out with 5/3. So find out all solutions if 5/3 is a factor. All solutions starts with 5/3. And 12 over 18, that looks like 6 going into 12 twice, 18 3 times, 2/3, and negative 1. So you get down to a not factorable quadratic or a not easy to factor quadratic, use the quadratic formula, which is exactly what I'm going to do here. So negative 4/3, set it up, same as the last problem. Okay, 3 goes into 6 twice. 2 times negative 4 is negative 8. 3 goes into negative 21 7 times. Negative 4 times negative 7 is 28. And 3 goes into 18 6 times. Negative 4 times 6 is negative 24. So that gives me my 0. And now I have A, B, and C. 2 numbers. Well, that's 6x squared. I don't even want to mess with that. I'm just going to set up the quadratic formula. Negative 21. We get negative 21 squared minus 4 times A, which is 6, and C, which is 18. All right, I'm going to pause it and pick up my calculator. Okay, it turns out that 21 squared minus 4 times 6 times 18 gives a 9, because 21 squared is 441, and 4 times 6 times 18 is 432. I got that 9 and thought, oh, well, that's just way too easy, but it is the way it works out. So now I'm just reducing and they expect us to calculate both of them. 21 plus 3 gives me 24 over 12. That's 2. And 21 minus 3 gives me 18 over 12. Okay, so my 3 solutions are negative 4/3, or my 3 zeros. And 24 divided by 12 is 2. 18 divided by 12 reduces to 3/2. Okay, last couple questions. The graphs of the polynomial functions are given below. What's the lowest possible degree? All right, so we have obviously 2 zeros here. There's a single 0, and this is a 0. Because our graph goes down and comes back up, this has to have an even multiplicity, 2, 4, etc. So we have 1 0 here, and the lowest would be to add 2 to it, or 3. Well, actually, let's just put that near this graph because I got one more to look at. Same idea. We've got a multiplicity of the part of the graph. So that's either going to be a 2 or a 4, but I'm just going to leave the 2 because they asked for the lowest. This is also a 0 here on the left, and on the right there's another 0. So our lowest number of possible zeros there is going to be 4. So multiplicity shows up on the graph. And they're only asking us about even multiplicity. If it's odd multiplicity, and I think that's tougher, which is why they probably didn't ask, then you see a different behavior. If it's odd multiplicity, I'm sorry, I can't help myself, then your graph is going to come up to the 0, it's going to flatten out, and then it's going to keep going. So that would be a multiplicity of 3 or 5 or 7 or so. All right, that's it for these notes. See you in class.